Hello students, welcome to the next lecture on the Legendre polynomial. Today we will see how we can derive the Rodrigues formula for the Legendre polynomial. Myself Dr. Harish, you can follow and subscribe my YouTube channel where you can find the playlist of the ordinary differential equation. The complete differential equations start from the concept of the differential equations, variable separable, linear, homogeneous, Bernoulli, and up to the Legendre equations, Frobenius methods, and many more lecture available in this playlist. Our last lecture was on the Legendre polynomial. Now, as we have discussed in our previous lectures, we have started the complete lecture series. The first three lectures we have already uploaded. Today, we will cover the topic Rodrigues formula. After that, we will cover the generating functions, orthogonal problems, and finally, we will cover the CSR net and the gate questions. So, as we have discussed and derived in our previous lectures, Legendre differential formula is defined by using x1 minus x square y double prime minus 2xy prime plus n into n plus 1 of y, and the corresponding solution is Pnx, which is called as Legendre polynomial of the first kind. By choosing the different value of the n, for example, if you choose n is equal to 0, you can compute the value of the P0x. If you choose n is 1, then you can find the value of the P1x after substituting into this expression, and then you can get the value of 1, 2, and then so. However, when you try to solve for the larger n, then you can see there is a need of a lot of the calculations. Fine. In order to overcome these limitations, or in order to make our calculation easier, we will try to generate Pnx Legendre polynomials from the equation number 1, and that is quite easy to compute the values rather than by using the previous formula, and that equation number 1 is called as the Rodrigues formula. The proof is a very simple. I can complete the proof in just the 4-5 lines. In the subjective examinations, always ask the state and prove the Rodrigues formula. Fine. 90% चांसेस होते हैं कि आपके एग्जाम में ये क्वेश्चन आएगा ही आएगा. चलिए, the statement as I define you, the proof is a very simple. First of all, by the definition of the Legendre polynomial, we know the Pnx is defined by this formula. That means अब हमारा टारगेट क्या है? We can start from the right hand side and try to prove is equal to Pnx. Look at that. If I use the binomial expansion, you all knows what is the binomial expansion of x minus a raised to power n. That will be nc0 x की power a power, fine, plus nc1 and so on. तो इसको मैं summation की form में लिख सकता हूँ. So I can write the binomial expansion on x square minus 1 raised to power n. Summation r varies from 0 to n. NCR, what is the meaning of the NR? That is equivalent to the NCR. Fine. Now you can open that. That will be N. R varies from 0. NCR is a minus 1 raised to power r. I can write as a x raised to power 2n minus 2r. Fine. I can differentiate n times on the both side. Clear? Now differentiation with respect to x, so that up to this quantity is my constant, which I taken as the outset, NCR minus 1 raised to power r, nth derivative of the x की power 2n minus 2r. We all knows how we can find the nth derivative of the polynomial. So if I say d of n x raised to power n of, fine, so that is two cases: 0 whenever m is less than of the n, and it is m factorial, over m minus n factorial whenever m is greater than equal to x की power m minus n. यही होता है आपके पास. So I can substitute the values at this point. तो ये मेरा m हो गया, m is equal to 2n minus 2r, और n तो मेरा n है, So first of all, whenever m is less than of the n, what does means? That means n is less than of the 2r, then this derivative will be 0. Or you can say whenever r is greater than of the n by 2, that derivative is 0. On the other hand, whenever r is less than equal to n by 2, you can substitute the value in the expression of m factorial, like m factorial, m minus n factorial, x power m minus n. I can substitute the value in the given expression. फाइन. नाउ उसके बाद क्या रह गया आपके पास? आई नीड अ 1/, फॉर्मूले में देखो आपको क्या चाहिए, और आई कैन मल्टीप्लाई बोथ साइड बाय 1/2 की पावर n एंड फैक्टोरियल. यहाँ पे 2 दोनों तरफ मल्टीप्लाई कर दो, यू विल गेट एक्सप्रेशन. अब आप इसको सिंप्लीफाई कर लेते हैं. सो दैट इज माई r वेरीज फ्रॉम 0. ये आपका ग्रेटेस्ट इंटीजर बन गया ना? या आई थिंक क्लियर होगा, बिकॉज जैसे r की वैल्यू n by 2 से बड़ी है, आंसर इज 0, एंड व्हेनेवर r इज लेस देन इक्वल टू n by 2, उसका आंसर ये आ रहा है, दैट मीन्स अ ग्रेटेस्ट इंटीजर. फाइन. चलिए इसको कैसे लिखे? एनसीआर को ओपन कर देता हूं. n फैक्टोरियल n माइनस r फैक्टोरियल इंटू r फैक्टोरियल, और ये वाली वैल्यू भी आपकी आ गई 2 की पावर n फैक्टोरियल माइनस 1 की पावर r 2n माइनस 2r फैक्टोरियल over n minus 2r factorial. Now clearly say n factorial and n factorial cancel out. तो बाकी आप चेक करो, यही एक्सप्रेशन बच गया. 1/, ये हो गया n minus r factorial minus 1 की पावर r 2n minus 2r n minus 2r and x की पावर n minus 2r. So which is nothing but my pn, और यही आपके पास रॉजिड्स फॉर्मूला है, and that is the required proof of the Rodrigues formula. Fine. Now, based on this, earlier in our previous lecture, we have derived all these polynomial based on the expression of the first kind. Now, today I will find the values of the p0, p1, p2, p3 by using the Rodrigues formula. So I can start from here. So by taking n is equal to 0, तो क्या बन गया ये? p of 0x, n की वैल्यू 0 फिल कर दो. 2 raised power 0 is 1, 0 factorial is 1, the 0th derivative is my 1, so p of 0 is my 1. Clear? Similarly, by taking n is equal to 1, it's a p1. Fine, it's a 1/2 की power 1 factorial, first derivative of x square minus 1 power 1. तो ये कितना बन गया? 1/2. फर्स्ट टाइम डेरिवेटिव इज 2x, so 2 and 2 will be cancelled. p1x is my x. Similarly, when you take n is equal to 2, what is the value of the p2x? 1/2 की पावर 2 factorial, second derivative of x square minus 1 square. फाइन. तो करते हैं इसका डेरिवेटिव, ये कितना हो गया? 4 into 2, तो फर्स्ट टाइम डेरिवेटिव करो इसका. फाइन, इसे ट्वाइस एक्स स्क्वायर माइनस 1, और एक्स स्क्वायर माइनस 1 के साथ करेंगे 2x, फिर आ गया, तो ये 4 से 4 कैंसिल हो गया. सो 1/2. फाइंड d of dx, इसकी ब्रैकेट खोल दो, दैट इज एक्स क्यूब माइनस एक्स. नाउ इफ यू ओपन द ब्रैकेट, सो फर्स्ट डेरिवेटिव 3x square minus 1 is the required expression of the p2x. Similarly, by taking n is equal to 3, you can find the third derivative. 1/8, 3 factorial is 6. सबसे पहले पहली बार डेरिवेटिव करो इसका, so that will be 3 into 2x into x square minus 1 square. Find 3 into 2 6, that will be cancel out. 1/8. तो एक बार फिर से डेरिवेटिव कर देते हैं. सो आई कैन अप्लाई द प्रोडक्ट रूल. x के साथ करेंगे 1 एंड देन x स्क्वायर माइनस 1 स्क्वायर प्लस x इंटू ट्वाइस x स्क्वायर माइनस 1 इंटू 2x. x स्क्वायर माइनस 1 यू कैन टेकन एज ए कॉमन. फाइन, थोड़ी सी कैलकुलेशन कर लेते हैं, अदरवाइज यहीं पे सॉल्व कर लो, अदरवाइज यू कैन टेकन एज ए कॉमन, कितना रह गया अंदर, x square minus 1, that is a common, is a 4x square. Fine, so that will be 5x square minus 1, and then you can take as a one time derivative. After that you will get the expression is 5x cube minus 3x divided by 2 is the required value of the Pn. Fine, but if you look about these values, there is a very surprising result whenever n whenever n is my even. Fine, look at that, P2, P4, the required degree of the x is also even. कहीं पे भी x लिखा होगा वहां पे even ही होगा, लेकिन अगर ये odd है देन पावर भी सारी आपके पास odd ही आएगी. सेकेंड, अगर आपके पास Pn है, इसका जो भी पॉलिनोमियल आया है उसकी डिग्री कितनी होगी, n. यू कैन चेक दैट. जैसे आपने P2 लिया तो इसका आंसर जो है डिग्री 2 में ही है. P4 डिग्री 4, P5 डिग्री 5, P3 डिग्री 3, P1 डिग्री 1, P0 डिग्री 0. So this is the way you can state and prove the Rodrigues formula. In our next lecture, we will study the next topic, which is named as generating function of the PNX. Till then, you can share this video with your friends, like and comment on the videos. Happy learning, students. Thanks for the watching.